Dear student, in this video, I'd like to explain hypothesis testing for 1 week. First of all, let's start with the first example we have. A psychologist believes that the average IQ score for 2 years child is less than 20. A random sample of 45 children were selected and the IQ test have been administered. So use alpha 0.05 to test the claim using traditional method or p-value method. We can do both. So the data is available in iq.rds. We have already downloaded the data. It's there in the environment. We can see that it has 45 observation of one variable. If you click on the data frame, you can see only one column because we have only one variable here. The variable name is IQ test. Now, since we have said that to claim that the IQ score is less than 20, so this means we are trying to use left tail test. So first of all, before we apply the test, we need to compute the average, the standard deviation, everything, then we can compute. So we will call the average for the first example x as x bar 1. Compute the mean. IQ is a file name $IQ test. Run the code. It will be saved here in the environment with the file name x bar 1 or as a vector or as just one single value as x bar 1. We will save the standard deviation as S1. So the command for standard deviation is SD. File name is IQ $IQ test. So the standard deviation is now saved. We also need N1. The command for sample size is nrow IQ $IQ test. We also need alpha. It's given in this problem, alpha value is 0.05. Okay, so let's save everything here in the environment. Already we have saved as standard deviation, N1 is saved, alpha 1 is saved also here, 0.05. Find the critical value. Why we say here Z not T? Because the sample size is big, we have 45 observations. So the critical value for Z, since this is left tail test, the critical value of Z will be negative. Left tail means the region you have it in the left side as you study in the theory class. To get the critical value, the command is qnorm. And for the left tail test, we put only alpha value here in the bracket. So we get a negative answer. If it is a right tail test, we use 1 minus alpha to get a positive number. So save the critical value as Z1. Okay, so that is minus 1.64. If we want to round it to 2 decimal places, we can round that. Compute the test value. Test value, the formula we learn in the theory class, that it's x bar minus the value of the mu divided by standard deviation over square root of n. So we'll apply the same formula here. So mu means the hypothesized mu we have here used. So mu is 20. Let's save the test value under TV1. Let's calculate now. The value of x bar we have saved for this question as x bar 1. X bar 1 minus the value of the mu. We did not save it. We can just write it 20 divide by the value of the standard deviation is saved as S1 over square root of N1. So now we have saved the test value. The test value is also negative because this is left tail test. If you just observe, the test value is coming before the critical value. So it's not in the critical region. That's why we have to not reject the H naught. So the critical value, the test value is not in the critical region. You can draw the curve and show that the test value is not in the critical region, so it's not rejected. H naught is not rejected. We can also find the p-value for z-test. The p-value for z-test is a probability that z is less than the test value. To get the probability of any normal, we use p-norm. P-norm is a code for cumulative probability, means probability of z less than some value. So what we will do here, we write p-norm, and inside the p-norm, we write the value of z we are using. Test value we have saved as TV1, so we'll use TV1. Now, if we are using p-value method, we compare the p-value with alpha. So alpha is given 0.05, p-value is more than alpha. That means, again, we fail to reject the null hypothesis. Fail to reject. So in both methods, it is evident that we have not to reject the H naught, fail to reject H naught. Because also using traditional method, we found that test value is not in the critical region. So that's why H naught is not rejected. Okay, now let's see the next question. A researcher claimed that the average cost of particular brand of shoe is more than 74. This time we are going to use right tail test. A random sample of 36 shoes. So the data file is saved here. The n is 36. Again, we use normal distribution. The data is available in the file name shoes. Okay, test the claim as alpha 0.01. So first of all, what we have to do, we need to get this information. How much is the sample mean? We will save it as x bar 2. Mean is a code for the sample mean. The file name is called shoe. See here, the file name. As it is written in the environment, write its same shoe. And then if we have only one variable, we have to select that variable available, cost. So standard deviation you need to calculate. The command is sd. And then the file name is shoe dollar cost. We can save also n2. It's already there available 36. If you want to use the code, you can use this code. N row file name dollar cost. Also, you can see the value of alpha. Let's save it as alpha 2. Alpha is 0.01. Find the critical value. If it is right tail test, this is right tail test. The critical must be positive. So we have to use, again, the code is same, but we have to use 1 minus the value of alpha. Okay, so we did not save the alpha. If you run the code, you will get the value of the critical 2.33. You can save it as Z2 if you want to save it in the environment. Save it in the environment, 2.33. Compute the test value. Okay, how do we compute? We've studied before. To compute the test value, we use this formula. So we'll use it again here. We'll save the value of the test statistic under TV2. So the value of the mean minus the hypothesized mean in the question, it says 74. 74. divided by standard deviation is saved as S2 divided by square root of N2. Save it as TV2. It's 0.313. You can see it here. So what we have to conclude, the critical is 2.33 and the test value is 0.313. As you just draw the curve, you will see that the test value is in the non-critical region. So again, you fail to reject H naught. Let's calculate the p-value. P-value in this case, if it is right tail test, so p-value will be probability that your Z is more than the test value. We can't get the probability of more than in R. We need to use it complement rule. So 1 minus probability of Z less than test value. This probability can be found because this is cumulative probability. So what we will do, we'll use 1 minus this probability we can find by using the code. P norm is a code for finding probability in normal. And then we write the value of the test TV2. Run the code, we get this p-value. If you are using p-value method, compare the p-value with alpha. Alpha is 0.01, p-value is more than alpha. P-value is more than the rejection probability, so that's why we fail to reject H naught. If p-value is smaller than alpha, then we have to reject H naught. So this is regarding normal distribution. Left tail I completed and right tail also. Let's move to T distribution, left tail. A hospital manager claimed that the average time taken by its patient to wait till they get service is less than 20 minutes. A random sample of 15 patients were interviewed and the waiting time was recorded. The data is available in the file name called waiting. We have already downloaded the file. This is the file waiting. Okay, so use alpha 0.05 to test the claim. Find the critical value. First of all, let's calculate the sample mean. Let's save it as x bar 3. So mean for the waiting $time. We have only one variable, so we have selected that variable. We want to find also S3. I will run all of them together. SD. Okay, so we can just take this because we are repeating inside. We can have the n value by taking the command nrow and then we have to also enter how much is alpha. Alpha in this question is 0.05. Okay, run all these codes so it's saved in the environment. Find the critical value of T. This is left tail test, left tail test. So the value of the critical will be negative. Critical value will be start with the code Q, and then this is a T distribution, so we write T. In T distribution, we must write the degree of freedom. So first of all, we write, because it's left tail test, we write directly alpha. Then the degree of freedom is equal to N3 minus 1. So we save the critical under the name of T3, let's say. If you just observe, the critical value is in a negative sign because this is left tail test. Now we will compute the test value as we did before. So the test value formula is this one. So whether you're using normal distribution or you're using T distribution, the formula for the test value is same. So first of all, let's save it as TV3 equal to the sample mean is x bar 3 minus The value of the hypothesized mean in this question, it's written as 20. So 20 divided by standard deviation, we save it as S3 divided by square root function of N3. Run the code. Your test value is saved in the environment. If we want to run it here, you can just type it again. So that is the test value. So compare the test value with the critical. The test value, if you just draw the curve, you will see that the test value is in the non-critical region. In that case, you have to say that we fail to reject the null hypothesis. Find the p-value. P-value for t is, we say that t is less than the test value. As we did in normal, this is a cumulative probability, so we use p, t, and then the value of the test, comma, degree of freedom equal to N3 minus 1. So comparing, okay, yes, we have made the mistake here. So the p-value is again more than alpha, which is more than 0.05. So again, the conclusion, we say we fail to reject the null hypothesis. A researcher, now let's see the last question we have. A researcher assumed that the average height of buildings in the city is more than 600. A random sample of 10 buildings is selected and the height in feet are shown. At alpha 0.025, is there enough evidence to reject the claim? Use height. Okay, find the critical value for this. First of all, this is a right tail test because we have mentioned here testing the claim that it's more than 600. The file here is named as a height. So we need to get, first of all, the sample mean, x bar 4, we save it. The command is mean. The file name is heights, dollar, again heights. Sample standard deviation, we save it as S4. The command is SD, heights, dollar heights. Sample size, we save it as N4. The command is nrow, heights, dollar with heights. And alpha is given in this problem is 0.025. So I'll save it as alpha 4, 0.025. I'll run all the code together so that everything will be saved in the environment. Find the critical value for t. This test is right tail test. So the critical value will be qt. It should be positive, so that's why we use 1 minus alpha. Alpha is saved as alpha 4. T distribution also has degree of freedom, so we have to mention the degree of freedom for this example. Degree of freedom will be number of the sample we have minus 1. So if you want to save your critical value in the environment, you can just name it as a T4. It's saved in the environment. I want to recall it in the console window. I can type again. Compute the test value. The formula is again same for the test value. So what we will do, test value for this question, we save it as TV4, x bar 4 minus the hypothesized mean, which is 600, divided by standard deviation, we save it as S4, divided by square root of N4. Recall the TV4 in the console window. It's 0.188. if you compare the test value with critical value, test value is again falling in the non-critical region. So our conclusion is fail to reject H naught. If we want to find the p-value for right tail, p-value for right tail will be probability that t is greater than test value. So it is same as 1 minus probability that t is less than the test value. So 1 minus pt, because we cannot get a probability for more than, that's why we use a complement rule. We say 1 minus probability that t is less than test value. And this probability, we can get it using commutative command, which is pt. The test value, we save it as tv4, comma, degree of freedom. For this question is df. Degree of freedom is n4 minus 1. So run the code, you get the p-value more than alpha. Alpha is 0.025. Again, we have reached to the same conclusion, that fail to reject H naught. That is regarding our hypothesis testing for one mean. Thank you.